and start off.
So we've started the Robot Builders Night Out, the virtual version, for August 4th. And I guess Carl is on the road, and I'm not certain if he's going to be joining us or not. Probably not, right?
Probably not.
Oh,
I mean, unless he's doing it off of the phone, because you can do it off the phone.
Oh,
but
yeah, that's true. Might be a little dangerous when you're driving.
It might be.
I've been known to do that. I'm just saying.
Oh, yeah.
Yeah, but you're the bad boy of the group, Harold.
Yeah, I'm the bad boy. No, Murray, I'm just the loud one, but I don't know. I think you actually own the bad boy moniker.
Oh, just because of the length of my hair, right?
Yeah, something like that.
Yeah. Tell you what, I can wear my pink pussy hat. How's that?
Don't you have to pull the ears out?
Oh, okay. I'll give it a try.
Okay.
I got this from a woman in Florida who's being harassed. I bought 8 of these from a woman in Florida who was being harassed online. So I decided I'd buy them, and she donated all the money that I sent her to the I don't know, women's shelter or something like that.
Yeah.
Anyway, that's as much as the hat sticks up, I think.
Oh, okay.
In any regard.
Anyway, so there's the little Pi board, and I created a 3D case for it. It's based on the 407, and it's got very good support for, I'll probably say one and it's the other. It's either I think it's MicroPython, not CircuitPython. Maybe wrong about that. But
what's the name of that board?
What's that?
What's the name of that board?
It's just called the Pi board, PYBOARD.
Who makes it?
O1 Studio makes it. That's, it's Banggood. Adafruit carries something similar. It's not identical to this, but this was like, I don't know, I think around $10. Adafruit's was about $40.
Is it a Seed Studio?
I'm not certain if Seed Studio carries that. You can look at Adafruit. I'm pretty certain. Just look for.
Okay, I'm trying to find it. Pi board.
Yeah.
Okay, I'll post it if I can find it. Anyway, go on. Sorry for the interruption.
So that's one of the other boards that plugs into kind of this base, and the base has it's got a 2.4-inch LCD on this side. And either the Pi board plugs into it, which is based on the SEM32 F407. There's an adapter board for the OpenMV H7 camera, so you can plug the camera into this board and then onto this, and use the display like you could use the display on the back of the camera that you can give that board. This is an ESP board, ESP32 board. It's they're all about the same size, but based on different processors. That can also plug into there. So there's 3 boards that you can program either in C or Python to do different things, and it's got built-in battery charging and some linear voltage regulators on it. A little buzzer, a little temperature sensor, a little humidity sensor. It's kind of set up. They're not quick connectors, but they're the same sort of thing. They've got plenty of quick connectors here and here. And
so, how much did the board cost, and where'd you get it from?
I got it all from Banggood. I've been waiting for, seems like forever to get this stuff in, but I had the Pi board once before, and before any of that. I think I got that late last year, and I've done some programming with it in Python, or MicroPython. Where did you find that on?
Yeah, I posted a link. Is that it?
Oh, I didn't look. Let me see.
I found like it reminds me a little bit of the Itsy Bitsy. I mean, different form factor, but it's like a small board that's actually quite powerful. Yeah.
Yeah, that's it. Oh, it's the 405, not the 407.
But yours is like 168 megahertz. Something like that.
It's the same specs as that one. I don't know. It's either 168 or it's very fast. Yeah.
Yeah, because I think the Itsy is like 120, so this is even a little bit faster. Yeah, it's cool.
It might be. Oh yeah, that one says 168 megahertz. Wow.
Yeah.
That's very fast. Yeah. I think they can go, the same speed. Because they're based on the same processor, and it's Cortex M4 same board, but a little bit different. Like this one has, and I think they were meant to be broken off if you didn't want them. It's got like a boot switch, a little, resistor and LED for power, just to show that the power's on. And it's got a couple screw holes on the side of it. I don't know if you can see that very well.
Oh, yeah. But that's slightly different than the one that Adafruit's selling.
Yeah, but it's the same pinout and form factor. It hangs over a little bit on the edges, but so it's just, I don't know, it just seemed pretty versatile, and the fact that it worked with the OpenMV H7 and all these other boards, I thought I'd get it and play around with it. So, but
yeah, it's cool.
And then I was trying to get, before everybody came on, I was trying to get one of the old Xbox 360 Kinects working with Raspberry Pi 4. Took a look around. I had it working with Raspberry Pi 3 B+, but it's a little too fast for OpenCV. The frame rate, and the size of the frame, apparently you can't reduce it down from the 360. You get like a fixed, I don't know if it's 320 by 240 or if it's larger than that. It may be the next step up. Maybe 640 by 480. It's a pretty big image to work with.
But you're trying to build it. You'd like to work with a smaller image?
Yeah. It's just TMI. There's too much information.
Yeah. Well, one of the things I found is like on the Raspberry Pi is that you have to dig quite deep into the configuration files that on boot up to find out where you can specify the actual frame size. And my guess is that somewhere there's some line somewhere where you can say how big you want it. It probably would go down to smaller.
Yeah.
It's sort of like an X Windows configuration,
Say that again.
It's sort of like an X Windows configuration.
Yeah, I don't know that much about it. I think I would have to, well, kind of in the reverse engineering, there's a set of registers, and I'd really have to dig into the code. I was for the the Xbox 360. You might be able to change that. I don't know. Maybe they set it up so it was fixed format. Anyway, I kind of got interested in that. I saw an announcement for it was a new Intel RealSense camera, which is their depth cameras.
Yeah.
And the older ones they've gone down in price, I think, because the introduction of the newest one, which is the newest one, the LiDAR depth camera L515.
Are those something like a cigar shape?
They're pretty small, yeah. Maybe, I don't know.
So have we lost his voice? I'm not hearing Ray.
Oh,
you're not?
Yeah, I can hear him.
John, hello. Can you hear me? Let's see how big it is. They give dimensions. 61 millimeter diameter by this one is circular. 61
Oh,
millimeter diameter by 26 millimeter height, and that's the L515. And that's supposed to be a little bit different than, I think they're actually using I think they claimed it was like the moving mirror technology that TI used. Not certain quite how they're using it, but I was looking at I think it's the D 435. Oh yeah, that was kind of interesting. They also have a version with the BNO 055 in it. It has
really?
a suffix with the I on the end. Yeah, so I thought, well, okay, so you can get inertial measurements and depth, at the same time. So
cool.
Anyway, so that's one of the things that I've been waiting for a long time. It's like this Simpsons episode where Bart is looking for his spy camera. Where's my spy camera? Anyway, so that's what I've been up to. We should probably pass it on to somebody else.
Okay, I don't know which one of the Dougs we want to go with, but I'm thinking the one Doug I see in the background, a 4-wheel thing back there.
Yeah. Tell us about that.
So you want to tell us about it? And is that the one you're going to go with? Have you figured out which board you're going to go with?
This is just a toy that I bought so that I could have something that rolls around on the thing. It has a Arduino in it, so I got a chance to practice with Arduino. That's the name of the company, upside down, of course. And the unit itself has got a number of sensors in it, but unfortunately, because it's a training thing, you can only play with one sensor at a time. You unplug what you're using, plug the next one in, and train on that. So it's not a real functional robot, but it did give me a chance to play with actually assembling things, because I'm a software guy, and now I finally started screwing something together. So that was good. And I've got a bunch of bits that I can put on some other robot at some other point. The car actually worked. It had a remote control that I could run it around with, and it also could run autonomously to do certain things. Like this was used to avoid things. You could put your hand in front of it and it would back up and leave you around and everything. But very simple little toy, just something to practice actually doing something with. And at some point, I want to actually start building what I think of as my real robot. But of course, it's real hard to find bits and pieces around here. Radio Shack is gone. Fry's is practically empty. Micro Center doesn't have much, and nobody else. I can find places to go buy bits and pieces, like pieces of aluminum to hook things together and things. Where do you guys buy stuff?
Rev Robotics?
Pretty much everything is online.
Right.
Yeah.
That's what I was afraid of. I wanted to just meander around the store and load up a cart, but that ain't gonna work.
Come on.
Hey, have you heard of Rev Robotics?
I've seen that name on your webpage.
Yeah. Yep. Yeah. As far as they're in, I guess that's considered Carrollton. I don't know where you live, but pickups and stuff. They have a ton of stuff that's aluminum rails and or stamped aluminum pieces and gears and sprockets and chains and motors and.
But do they sell retail?
Oh yeah. You can go to their website. I don't know if they encourage pickup. If you wanted to pick
right,
up.
that's what's my question. Is it basically a red-based company?
Yeah, the thing I would say is if you want just aluminum, try Garland Steel. They have a bunch of aluminum in different forms that I've gotten. I mean, it's not it's just sheet metal kind of stuff.
Yeah, I was looking for something to build the base out of that I could then hook the wheels onto and the basic structure.
Hey, Murray, can you show your Can you show your robot that
Yeah, sure, I will. One thing I'd suggest
you might like to see the real system you're using?
Okay, yeah, I'll do that. Doug, one thing before we go on to that, I was going to mention this whole idea with this robot toy that you've bought is that for every sensor, what you're doing is writing or using a little bit of code that reacts to that sensor. And
Right.
if I don't know if you've been following my little rant on the mailing list, but I kind of got started in this about a year or so ago by kind of rereading a guy at MIT's AI lab named Rodney Brooks, who's a researcher. I think he's probably retired from academia now, but Rodney Brooks is an Australian researcher who's done a lot of work in what's called behavior-based systems. And in a short a nutshell as I can make it, every sensor has, if you think about it as a module that's both hardware and software, there's a sensor and then there's a corresponding bit of software code. And that software code basically says, if you see something from this sensor, do something. And that do something is, let's say, maybe back up or turn left, and there's both what they call servo behaviors and ballistic behaviors. A ballistic behavior basically says, do this until you're finished with the behavior. So it means back up for 4 seconds, turn left and go right. That's a ballistic behavior. Most of the rest of them are servo behaviors. But all this BBS stuff is basically saying for every sensor, you've got some kind of an associated behavior. And these behavior-based systems are simply a conglomeration of a bunch of sensors and their behaviors. You put that robot on the ground and it exhibits an emergent intelligence. That's basically the idea that Brooks had.
Right.
And so what you've got there, if you can take those sensors and for each sensor program a behavior that the robot will have based on that, and then you prioritize those behaviors, put them all into a robot, and you have a BBS. And that's what a lot of people do. So all of the work you're doing right now, learning how to react to those sensors, if you keep the code for each one of those, you're building a collection of what becomes your operating system for your robot.
Right.
So,
my assumption is that the actual robot would have multiple boards, like 3 or 4 Arduinos, each kind of taking care of some things.
well, you can. Okay, I'll hold my robot up now.
Yeah.
I would recommend not using metal for the frame of your robot because it's conductive. I use 3mm Delrin plastic, which is a form of acrylic that's a little more durable. DELRIN. It's very, very strong. It's almost shatterproof. And I built my robot on top of a frame that Ray is showing a very competitor's. It's using, actually, I've got one right here.
And you can still buy stuff from MakeBlock.
MakeBlock, and there's a company up in Vancouver called OSEP, O-S-E-P-P. And they're quite a small company, and they make these aluminum channels. And MakeBlock is another company. They basically build either red or blue channels into a robot. I bought a couple kits and put them together, and this is what my robot looks like. Now, underneath, you can see the red channels that I built the frame out of, and the motor's attached to that frame, but I don't attach any electronics to the frame because I don't want to worry about things actually conducting. So what I did was I used a bunch of little spacers, and I put a Delrin platform just above the metal frame, and that's where I mount everything. So I've got 2 of those. I've got a lower level, I don't know if you can see that, but I've got a lower level Delrin piece, and then another one, and there's just spacers between. And I put all my motor controllers between them. And then I've got on top here is my Raspberry Pi in the back. And as you were saying, multiple processors, I've got a little itsy bitsy processor here that talks to the Raspberry Pi over the I2C bus. And basically you see that little light flashing. That's actually that's the Arduino, which is actually an itsy bitsy, but it's an Arduino clone that is reacting to the infrared sensors on my hand. So it's can't stay far away from it. There, red. Okay, let's see now. So red is the port side. Green is the starboard side. The very center is blue. Then the 45-degree is yellow-green, and the 45 on the other side is orange. So basically, that thing is reacting to the infrareds and sending signals to the Raspberry Pi. And that offloads that process to the Arduino so my Raspberry Pi can do other things.
Right.
So I've got this sensor on the front, which is what I call an integrated front sensor. It's basically just an aluminum frame with this piece of polycarbonate with some lever switches. So I can basically get the signals from the lever switches and the infrareds on the front of the robot all come through that itsy bitsy processor. And I can just basically query that processor and say, have you seen anything? And what I'm doing is basically saying that whole collection of sensors on the front of my robot is now a single sensor. And I can just query it and say, what do you see? And the robot will say, I see, and then I can see something on the infrareds at, 6 centimeters and something on the left port side at 12 centimeters, and there's nothing hitting the bumpers. And I can then program those basically fire off events inside my operating system, which is written in Python, and those events are prioritized. And then basically this, it's called a subsumption architecture. My robot will then take those events in a constant stream, prioritize them, and then whatever the highest priority is what the robot will do.
Cool. So you're saying that the one itsy bitsy is able to handle all the sensors and still keep up with the processor?
It's itsy bitsy. I mean, an Arduino is only 16 megahertz, but this itsy bitsy is 120 megahertz, so it's actually quite fast. I mean, although an Arduino is plenty fast.
Right.
But it's not necessary. I don't think this is entirely necessary because you could have the Raspberry Pi handle that too. But to me, part of the challenge was how to figure out how to make these sub-processors on my robot.
So basically, what you would have is a case statement in the main loop in the Adria code that you would call. So that's what, at least the way I'm interpreting it, right, Murray? Right,
well, it's not. I'll try to describe it a little bit more. Basically, all the sensors, there's what's called a message bus. And this is actually a common thing, like in Java or in Python. You just have a message bus, and it's or a message queue, actually. And it's just a thing where you can send messages into, and then you can have listeners on that message queue. And so all I do is every one of my sensors, I've written a little Python class for each sensor, and it basically sends messages into this message queue. And the messages are prioritized. So if the battery goes low, that's like the highest priority, and that'll shut the robot down. Bumpers are also a very high priority. Less priority might be, the long-range sensor. But all the messages going into the message queue get sent through what's called an arbitrator. And I'm not making this up. This is stuff I've been using this, but this is how other people do it.
I'm actually laughing at Ray doing the hard sell here. And
he's back,
But the key is you're talking like Java or that where they do have effectively interrupts. So in the Adria world, you would have to have like an interrupt or else a case statement in the main to simulate that.
What you're saying, John, but it's actually not like that. It's following this idea of a subsumption archecture, which is what Roger was talking about. And all it means
is terms, but you can.
But there's not really any interrupts actually. What's happening is that you have a whole bunch of sensors sending messages, prioritized messages.
Right.
You have it's called an arbitrator that basically listens to all those messages and prioritizes them.
Right. There's a main loop out there in the
main loop. Yep.
Right. See, that's why I said.
And then off the top of that, it sends the most the highest priority message into what's called a controller. And the controller interprets that message and then says, run this routine based on that, like shut the robot down.
Or a case statement or something. I mean, you can visualize it across languages that way. So, And that's why I was saying in an Adria board, you would have to do a little bit more coding to achieve that.
Mm-hmm. Effectively, the controller has a case statement in it because what it says is which message is it, and then it fires off a small, it calls the program based on which message is being chosen as the highest priority at that moment. Right. But that's in a nutshell how these subsumption architectures work, and that's what I'm trying to write. That's my goal in this was learning Python and learning how to write my own OS around that idea. And Python is certainly capable of that. I didn't have to write my own message queue. There was already a library for that.
Right.
But that's basically it in a nutshell.
So
it's a good journey.
When you all were talking about cases and that, so as Ray was showing off, they have the metal stuff you can get. Okay.
Yep, right.
You could laser cut your wood, plastic, whatnot.
Right.
And then if you have a 3D printer or can get one, you can print out the case or whatever you need. In this case, here's an example of the one that I printed out using basically the same words that you have on yours.
And if you have a Lowe's nearby and you want to use these little heavy, steel plates because they're heavier.
That's another option.
And along with John was saying on the printout, I printed a bunch of these. If you get on the Thingiverse and look up TurtleBot 3, this is printable. It's got supports built into it. When you print it, you start printing a bunch of them. And if they take about 3 or 4 hours on my printer to print per thing. And if you print a lot of them, you get to bolt them all together and make a pretty big sizable thing. How big do you want to make them is what it comes to.
Yeah, so Doug, I guess the question is that you haven't quite said how much hardware or what kind of hardware. Do you want to build from scratch? Do you want to build from a kit? How do you want to do it?
Well, I hadn't fully decided. My goal is to create.
I'm going to the wrong camera. I'm going to do everything.
The second robot I'm going to on is a home security robot. So it needs to meander around the house autonomously, and when it's told to, phone home if we find something going on that's not supposed to be happening. So I'm viewing something probably the size of R2D2 or maybe a little smaller. And I would like to not have to put every screw through a hole. It'd be nice if I could buy a base that I can then put the other stuff on top of. I've seen some online, but I'm not sure.
Yeah, there's a company up in Canada called robotshop.com, and I'm going to find, I just posted the OSEP tank kit that I use, but I know of a robot that Robot Shop sells. I can't think of the brand name, but robotshop.com sells tons of them. And they've got an R2D2 style robot. It's a cylinder about, well, it's not as big as R2D2. It's about $500. It's kind of expensive, but it is a kit.
I think you and I are thinking of the same one. I think DF Robot actually makes that. And let me go look and see.
I'll post the link in a minute.
I'm looking it up right now, but I want you to post your link too, and I bet we come pretty close to one another.
Okay. The other thing you can do is if you can't find what you want, metal parts,
motors,
3D print parts to go with your metal parts.
So the part of the question I would say is, how big does it really need to be to achieve what you want to do?
Exactly. I'm over engineering. I mean, I don't need R2D2 if this little car can handle it.
Right. So if it's something that's going to go around the house, it needs to be able to go over the carpet. Okay, so that would be the one criteria I would be looking at versus flat. So, like the size Ray has, for example, you can have a camera on that. You can have a stick on the top. If you need to have visual type thing. So the question would be partially, does it need to pick up something, or does it need to drag something, or is it more of a move-in platform with sound video?
Right. See, the security aspect is like the thing that got me thinking about it. But I'm also, of course, I always turn my Volkswagens into Cadillacs. So I'm thinking, well, think of it as a home assistant where it's like can do things and go pick up things for you. It can be like a mobile Siri or a mobile whatever that thing is Google does. Alexa.
Well, there's libraries that bring a Raspberry Pi into Alexa and do all the things that you were just talking about. That's a very doable thing.
Yeah. One thing I worry about with the Pi is that every time I look at a thing, they start using up all the pins. Now, Ray started off with this nice little expander board before we actually went live, and I didn't catch what it was that he did that, but that's an interesting idea. It expands the one Pi instead of having to have multiple Pis to talk to each other.
Yeah. Oh, well, the studio board, that doesn't work with the Raspberry Pi, but it does work with a lot of other boards that you can program with Python. So including one that kind of my favorite, the Open MVH7 board, which is a video camera with either a side-by-side LCD display or an LCD display that mounts in the back of it, so you can look at the back of your robot and see what your camera is seeing.
Yeah. Murray came up with something different than I did. So I put my DF robot one in there, and then Murray put his link in there for your R2D2 style robots kind of thing. You go see.
And they're kits. I mean, this one, the one I posted is actually an Arduino compatible, but these companies sell ones for Raspberry Pis and Arduinos. The one thing that I have to say that I would agree with John is that I think actually David Anderson mentioned this last week, is that there's a certain kind of interplay between the size of the robot and the size of the motors and the size of the batteries. Right. And there's certain kind of platform sizes. And when you get to a certain size, the size of the batteries goes up quite a bit and the size of the motors goes up quite a bit. And so I can only speak for myself, but the reason I chose the particular size for my robot was that I had an idea for the size of the battery I wanted and the size of the motors and the overall weight. So I kind of had that idea. These bigger robots will have bigger batteries, bigger motors, and they'll also potentially inside of a house do more damage when they run into things. And they will run into things. So I wanted something that was not threatening to my furniture, and something that the batteries I'm using, I chose to use these 18-volt power tool batteries because they're really durable, and they're not cheap. They're actually quite expensive, but I had a few of them already, and so I don't know if I showed you, but I've mounted even in the time that I've come up with it, it's a Makita power tool battery, and that's a 6 amp hour battery. It's 18 volts. It's actually around 20 volts in reality. And I'm putting a regulator off that. So long as the battery stays above about 17.5 volts, which is what the battery's lower limit is, I can get 5 volts off that easily. And I think my motors are tuned for 9 volts off a power supply. So I've got hours and hours of life off that one battery on a small robot. If you step up to a bigger robot, you might only have maybe an hour or two of battery life, and then you got to have the robot running over to a charger somehow and somehow connecting into a charger. So if it's going to run overnight, you got to have a battery that can run for 8 hours or 10 hours. And so those are the kind of limits you might want to think about it in terms of the size of the robot, what kind of batteries, what kind of battery life, how big the motors have to be to lug that battery around, because that tends to be the limits that you'll find when you're building a robot is batteries and motors and weight and things like that.
Good information.
And also, if you're worried about running out of pins, like IO pins, that kind of thing, there's these things out there called IO expanders, or GPIO expanders to be specific. I just posted an Amazon link out there, and that uses I2C to then expand how many GPIO pins do you want or need. You have to have a library to access them, but you can add a whole ton of them, and those things will have like anywhere between 8 to 16 per board, and those boards can be chained and addressable, so you can add 16, 32, 64 of those extra things if you need them. So that's not it runs over I2C. So you got how much you want. Yeah.
And what you'll also find is that a lot of the sensors, like I don't actually need that many pins, because most of my sensors are these little I2C sensors that are all connected in the same bus. So almost all my sensors are just connected through 2 wires. And that I2C bus, if you're using it, means that you're not using any GPIO pins at all. In fact, now that I've actually offloaded my front bumper sensor to that itsy bitsy, I'm almost using no GPIO pins, because that's where most of my pins were connected, was to my bumpers. So you might not need all those pins that you're thinking you will if you use I2C sensors.
And as far as that goes, on your little Play robot where you can only plug in so many at a time, right? You get one of the GPIO expander boards with an I2C thing on it, and now you can plug them all in. Because it works like an extension, but you got to have a little library to access them. I say a little library. And there's Adafruit makes a library. A bunch of people make a library to be able to deal with that stuff.
Yeah, it's called an Adafruit multiplexer. I'll post the link.
That works too. Yeah, that works too.
So on this chat place where everybody's doing these posting, do I need to be copying these out, or is there a way to save this chat?
The chat is on the website.
Oh, so good.
It'll be by next week. This video and those chat records will be on the website.
Oh, good. Okay. I've been trying to keep up with copying this stuff, and I thought that's got to be a waste. There's got to be a better way.
Yeah. So if it's in chat, that's why you'll often hear somebody say, can you put that in chat? Because, and it's a good habit to get into because then there's a permanent record of it. Now, Doug, can you show me your robot again?
Yeah, it looks very similar to the one that.
Yeah, I want to say, I think that's this. Okay, you're using 4 motors, so you're using a few extra. I'm trying to figure out why you're so GPIO limited. You should actually be able to hook pretty much almost everything together.
This Arduino board here, I have to keep unplugging these wires because it'll say plug from these sensors into wire 8.
Okay.
And that when I do this sensor, oh, that's got to go into 8. And there's only one little plug thing. So
you don't have to do it into 8. The only ones that you probably don't want to screw with are your motors.
So
others have their own little controller board down there.
So the question I have is
PWM. So you got to, you don't want to, that's a special pin, okay?
Right.
It's got a little more functionality. But the other ones, I mean, you can use practically anyone. And I wanted to give you, I'm going to put it in chat here, a link to some training material that we have.
Doug, it looks like it may be just the software that's saying you have to be on a certain pin. That if you went in and altered the software, you could probably plug those into different pins.
That's what I'm thinking.
Yeah.
So have you actually modified the code or are you using the code as is?
I've been using the code as is. I'm not a great programmer, and my first venture into Arduino, so I'm basically just following along their lesson plan.
Okay.
And the lesson plan will say, okay, unplug everything from lesson 2, because now we're going to plug lesson 3 plugs in.
Yeah, it's a good way to go, though. It's a good way to learn.
Yeah.
Okay.
That was the reason I did it. Y'all suggested it. It was a great suggestion because now I have my Arduino IDE up and running. I've got my Pi IDE up and running, and I know how to actually do that bit. And now I can start focusing back more on the logic again.
Okay.
Yeah, there's a lot of basic skills that you're learning as you go.
Exactly.
Okay. All right.
As
I've
far
got
as
a link I'm going to show you, Doug. If you look in chat, you can see it down there. Okay.
One for build more robots.
Yeah. Okay, the resources.
Yeah.
Now, this was a first pass at this course, so there's going to be some stuff, particularly when we get into the later subject, because of the limitations of the base that we were using, that probably aren't best practices. But I'm going to give this over to you, but I'm not going to put it in the chat. And this is the password, and it's this is fun, with no spaces and each word capitalized.
Ah, okay.
So in the meantime, Ray, you were showing some videos. So was that from last week? You got the lawnmower up and running?
No, I was just giving another example of bigger platform means much bigger motors. Those are wheelchair motors. And it runs off 2 riding lawnmower batteries in series, so it's 24 volts. But
and it can mow down your furniture in your house for you. So yes, that's the problem. Bigger is not always better.
Yeah, you got to be able to control the bigger one.
Uh-huh.
But I've gone one step beyond that. I actually converted another mower to hydrostatic drive, so it has a lot more power than those wheelchair motors could ever produce. So there's no hanging on to the backing of it or even lifting it up because now it's too heavy.
Wow. You're kind of like heading towards T2 territory.
Yeah. So
the terror lawnmower.
What I was going to say about the systems, a lot of them, they're not plug and play with another manufacturer. Like the Make Block stuff is probably not going to work with the Rev4 robotics or Vex or any of the other ones. And I think they do that. So kind of once you decide to buy a few parts, you're kind of locked in if you want other things to fit with them. So, but they do include, like the Make Block stuff, they had everything from right angle plates to motor mounts. So literally, you know, you just bolt it up, and they're made for, you know, they're made to work. It just takes 2 seconds to bolt things up.
Oh, yes.
So yeah, there's a perfect example. It's got wheels and shafts and fasteners.
Yeah, and they make like a self-balancing robot and everything.
Yeah, yeah. OOSEP can be OOSEP's going to be compatible to MakeBlock, but I don't know that anybody else is compatible with those two.
Well, OSEP and MakeBlock they're exactly the same size.
Right, right. Yeah, they're 8 and 16 millimeter spacing on their.
Yeah.
But even, yeah, there was some other things that I thought would work. I got it from Fry's, and the spacing is a little bit different. Those metal plates from Lowe's, those are spaced a ½ inch apart. So those certain holes on the MakeBlock stuff and that stuff just happen to line up. But for the most part, they are not going.
So you got to drill out and drill the hole, huh?
I've got some Acto bodies. Fry's might have some of this still laying around, but if they do, you're just lucky. And it's all their holes are spacing on 1.5 inches across and that sort of thing. Makes it real nice. But as nice as that is, I've opted not to use this on my robot because it's metal, just like Murray was saying. You know, yeah.
Well, I tend to agree with you, Harold, that, yeah, if you have a 3D printer, it's nicer.
Yeah, it's not that hard. It takes a little bit. Plastic's cheap effectively, you know.
And you can bolt it together to generate something like this, even to give you an idea of how you can get fancier.
Yep.
Well, here's
I thought
here's another example.
Metal's not conductive, right?
What?
Anodized coating on aluminum is not conductive, is it?
Yeah, there'll probably be a way you can get around that. So yeah, by spray paint rubber.
Yeah,
I'm gonna share my screen briefly because I've pulled up my early design of the KR01, the robot I held up. I've got the page that shows its original chassis, and I just need to find out how to. I keep trying to share pages, and my Mac keeps popping. There, I got it.
Okay, good.
And a lot of us, I'm probably the prime example. I like the MakeBlock stuff. Tanner's had it for between a half and a third of the cost that was marketing and packaging. So it was all very cheap.
So can you guys see that then?
Yes.
Yes.
Okay, so this is the OSEP stuff, which is the same as MakeBlock. Theirs is blue, OSEP's is red. I bought that tank kit and then found out, I wrote about this in my blog, but I found out kind of a bit late that the tank treads that they give you actually can't handle more than the weight of the robot as they design it. So I'd put the battery on and got everything running. I was using 4 motors rather than 2. And I found out that as soon as this is their little tank tread one, and it's really for an Arduino, and it's great because it's a lightweight, small Arduino, runs on 4 AA batteries. But if you try running it any bigger, and it's just not going to work. I mean, the tank treads just come off. But this playing on the kitchen table, you can see I've taken that original design and I've bought an extra set of girder beams, and I've started designing the 4 motor design because I didn't want to use just 2 motors. I have to say that the design of the hardware is beautiful. I mean, they really do beautiful machines, and the red anodization is really pretty. So this is my 4 motor design using extra beams. That's 4 motors. 2 of them have encoders. You can see the top 2 motors have got encoders on the backs of the shafts of the motor. That's for odometry. And I think, if I go back to, come on, hurry up. There we go. So let's see if I can. So this is actually the very first time I'd prototyped it. That's just using a bit of a cutting board rather than, it's just nylon cutting board, which is cheap, like, $3. And that was my first prototype using pretty much all the parts that I'd bought. And of course, nowadays my robot looks a whole lot different, but having a solid base like this aluminum base and being able to modify it and using a kit rather than having, because I've got machine skills, I could do metal and wood, but it takes a lot more time. And I kind of like having something that I can modify and play with, and it uses 5mm bolts and nuts and things. And it's, you know, you can kind of modify things and try out different designs. And so you could buy a kit, but I mean, like a completed robot kit, but you can also just go ahead and buy a kit of parts, sort of like a Lego robotics thing. And that's kind of what I wanted, because I wasn't really sure what I was going to do with my design when I first started. And in the end, that I went through about 2 or 3 permutations of that chassis until I got what I wanted. And then I haven't modified it since.
Doesn't Micro Center have one of those $300 make block build a whole bunch of crap kits where it's got like
they don't spend that much. They're cheaper than that.
I think it's expensive to do that, but
yeah,
you know,
they did.
a shopping cart, you know, maybe some of that.
It depends on what you like to do too. For example, I enjoy assembling the robots. I mean, the actual mechanical assembly, and so I almost design every part that I make. Now, a lot of mine look similar to other ones, but what I'm saying is, I would, you know, if I had $150 and I was going to sit there and say to you, buy a robot kit, I'd say no, go buy a 3D printer and then make your robot kit, because in the end you'll be much happier because it'll be your robot and it'll be the way you want it, and it's you, because you can't at this point of your robot, being a hobbyist roboticist, you really can't make. I mean, I could show you a string of robots from my early days, and you know, I'd never build another robot like that, you know. But you know, they're just, because you what you want to do changes. You get smarter, by the way, not a whole lot, but a little bit. You get a little smarter, and so you know, you'll learn some things. Now, if you go to that resource I told you, that course was based on a simpler version of the robot that you have. Okay, and it goes in and explains every part in detail, and there's a lot of good information in it. There's a lot of good practices which that robot doesn't follow, but once you hear him, you'll say, yeah, I wish it had that. And there's a whole bunch of other things that you want, and there is some code. There's some code there that you can use, and it's very beginner's level code, so you can enjoy it. And it's think of it as another extension of the course you're taking, okay? Because that's what we do. That's how we train people who are interested here. Well, the way we did, but and hopefully again in the future, if we ever get out of. I'm about to eat the wood here, and so crazy. But anyway, while I've got the floor, I'm gonna say I got almost this close to showing you my robot doing that line following thing. For Doug, you don't see it, but here's an example of a very similar robot that you have. You might even see some similarities to it. Now, it does have a lot of little fancy things, like it's got encoders on the bottom here for the wheels. It's using a mega board. It's using another processor here that has a camera on it.
Doug, could you hold that up a bit higher?
Yes, I was going to say.
I don't know. Can you see that?
Not well, but if you want to do a presentation, I don't know if you can present.
Wait a minute, let me look at my own stuff. If I look at my own screen instead of you guys, I can probably.
Yeah.
Okay. Yeah. So this upper part here is just to support this camera, but it's got probably the same motor controller that you have. It's probably got the same Arduino. It's an Uno board with a breakout board on top of it. I don't use AA batteries because they're just too damn expensive. So I use 18650s, I think they're called.
Lithium ion.
Yeah, so I run 3 of those. And on this, the motors are supposed to be rated at 6, but I think I run them at about under 12.
Well,
under 12. And
So-
they'll be fine. By the time they burn out, I'll be on another robot. So. But,
so the key thing there is basically Doug said is, you want to get component parts that you can integrate to the next level up
yeah,
as you
now,
go up.
for the next time we teach the course, this is the robot. Now you say, well, that's my robot with 2 wheels. It isn't, because the frame has actually been hand designed. It's a different frame. It corrects all the little problems that you would have with your robot. And but it does use all their parts. That robot kit is a real good value. You'll have those parts you can rebuild and rebuild and rebuild. But anyway, that one does use batteries. And that's why this one doesn't get used very much. But anyway, so like I said, I've been real pleased this week. Made a lot of progress. I've actually got my two boards communicating, and now I just pretty much have to tune up the PID loops a little bit. And I think next week I'll be showing you guys it running at least on a black on white, but I'm hoping to get to black and white and white and black. And we'll see how that goes. So real exciting progress this week. I finally got some time on it.
So I hadn't seen that robot before. Is that the new one that you built?
I've shown you guys that one before.
I don't remember that frame being that way though. That's why I'm like,
Yeah, well, this is using the Pi bit board, which, by the way,
okay.
As I've learned to resolve different issues with it, it's definitely not Pi. I said Pi, but it's Max.
Max Pi, yeah. MAIXPY.
Yeah, bit, BIT.
Yeah, you get the bit version. I have the
but it's
Ad-hoc version.
Actually, I think I made the right choice with the bit. It's really a nice little board, and it's getting to the point where you can't trust their. You can start off using their documentation, but if you want to do something that's on the, what's the other one? The OpenCam?
OpenMV.
OpenMV, isn't it?
Yeah.
OpenMV. Practically everything that's on OpenMV is actually supported.
Yeah.
So even though it might not be in their documentations, you can. So I'm real. Yeah.
Use it as a starting point. Yeah.
All right. So anyway, so I'm real happy with the progress I made this week on that robot. This is my main battle tank, and he's going to have his front end reworked. I'm going to try and make him deeper
Okay. Doug, can you move it back a little bit? Because I only see one little part of it. Oh, there we go. A little better.
Wow.
Yeah. So he's going to, he's got some nice motors on the bottom from Polo Lou.
Right.
And he's, he has just the normal 2-line 16 character, but he's also got a RF link. And
so the diameter of that robot is how big roughly? Is 14 inches across? Or
I think it's 12.
okay. I don't remember that, but
Yes,
fortunately for Doug, the other Doug, it would be hard for him to gauge size. But that's an example of a robot I'm thinking that would work for, run around the house type thing. That's about the right size.
Yeah. And like Murray hit on the big thing that if you really want it to stay in the field, I guess there's 2 ways you can do it. I have some security cameras, and every once when I go off, that's when I use them. When I'm here, I don't care. But when I go off, there's nothing I can do If they come in and steal me blind, there's nothing I can do, but at least I can check and know they didn't steal me blind, and it gives me some, I don't have to worry about it. You know what I'm saying? So you could have it where you have it on a charger station and it goes out and deploys and then comes back and just rests during the rest of the time, instead of having it roaming completely around all the time. Because, like I say, you won't be looking at it. And if you're having it to detect threats, that's going to take another level of sophistication.
Not only that, whoever breaks into your house, probably the first thing they're going to do is hit that thing with a baseball bat. So that'll be your first loss.
No. They'll steal your baseball bat and then use your baseball bat to hit your robot.
Yeah.
Well, I've gone ahead and bought a whole bunch of these little Octocams, which are actually Raspberry Pi 0Ws. So they're a little Raspberry Pi that's on Wi-Fi, and they have a camera, and you stick them on your windows, and they have a little red light, and you can see them. So people coming up to your house know that they're on a camera, which is actually a deterrent, which is really what you want. Right. They all come together and get collected on. I've got another Raspberry Pi now. It's a Raspberry Pi 4. That's the base unit, and it actually does an rsync and collects all the images off these cameras. Now, the thing about these cameras, they use a little operating system that's designed for the camera, which has motion control on it. So you can basically set how much motion has to be noticed by the camera to trigger either JPEGs or movies. So these things can actually run with either JPEGs or movies. They're completely configurable. They're not that expensive. You can put them in places where they're very conspicuous, or you can hide them. And if you've got a bunch of them around your house and you hide a few of them, you're going to get video of anybody in your house. But from my perspective, I'd rather have cameras that have little red lights all over the place, so anybody breaking in knows they're on camera.
Right.
It's better to deter people than actually try to catch them on camera, believe me.
Right. Robot's not going to tackle anybody.
No.
Yeah.
The robot's just going to get stolen or hit by the baseball bat.
That's right. Hopefully it transferred some video before it went down.
but if you're interested in an easier path on that what Murray's got is really nice. But another one is WYSE, WYSE.
Yeah, I got one of those.
Those are fantastic.
Yeah. Hey, for $35, Wi-Fi, remote, 14-day capture of stuff, the whole works. You know, it's relatively secure as far as who can see it and what you can do with it. And I'm digging it out right now, by the way.
Yeah, I'm glad you got one. I got one here, but
Well, part of the reason I went with this Octocam is that it is actually a Raspberry Pi, and I can actually SSH into it and actually play with it as a Raspberry Pi, because that's literally what it is.
Yeah. So this thing has a stepper motor on the bottom of it. You can control the up and down of this infrared. The whole works. It's $35, man. You plug it into USB. You connect it up to your Wi-Fi, and then you use your phone to connect up to it. Once you get it all relatively secure as as anything's going to be, I guess today. It sits there and just works and play, and you can put it in several modes. You can turn it off and on remotely, and you can put it on follow things. You can, and it'll do voice in and voice out. Wow. If you want to.
I love the voice.
I was away on something. I started talking to my dogs. I saw them laying around the thing, and I started looking around. Where's that voice coming from? It was pretty much fun. Freaks the wife out though. She don't like this thing.
No, I wouldn't imagine.
This is the $25 version that doesn't have the pan and tilt. So if you don't need the pan and tilt, you can get them even cheaper than what Harold's talking about. Mm-hmm. And what I did on mine is I have an outdoor patio that's covered, and it's kind of natural stained wood. So I just covered up the lens and painted this kind of brown, and you can't hardly even pick it up. You wouldn't even know it's up there. And as long as they're over and under an overhang, they're pretty much can be used outdoors.
Mm-hmm.
I mean, these are just. I used to buy similar stuff from China till these guys came around. I know this is made in China, but what I'm saying is, they really had, they're from, I think they're ex-Google, if I remember right.
Post a link to these things?
Yes. Can you post a link or do?
Oh, I mean,
It
just,
sounds reasonably priced,
oh yeah, they're great.
easy plug-in.
So is there a subscription?
Micro Center normally has a whole end cap full of these things for the $35, $25. Just walk by and pick one up if you're so inclined.
Yeah,
I'm not
I
do that.
just get mine at Micro Center, but you can buy them online. I'm trying to think of where. I thought it was
How do you spell it?
WYSE.
Okay. Micro Center. Is there a subscription? You know,
Yeah.
like a monthly subscription?
No, well,
You can pay for a subscription, but you don't have to. The base level, once you buy one of these units, gets you 14 days of online storage going on. There's an SD card in mine. I think Doug has one in his too. That you
I
can
found it.
do
Yeah.
time lapse and things, that sort of thing. If you want to record them, so you can record all your stuff local and then pop it out if you want.
I found it.
yeah.
It's. I think as far as bang for the buck, you're getting a lot for your money, regardless which model you get for this thing. If you want to pay for extra for like 30 days of things and long time storage and stuff, you can certainly do all that. But the base level, once you buy the camera, is pretty feature rich, I would say.
Yeah, pretty cool.
Also has things where you can put it in the mode to say follow, so it recognizes people and things, and will follow a person around if it sees movement in the room and that kind of stuff for a little while. It doesn't do a detect, or at least I don't think it does at the moment. But it doesn't remember who you are. It doesn't know who you are. It just knows you're a person and will follow you around.
Right.
And
They're actually improving their software all the time. I mean, they add features to it. I mean, you would think, that, well, once that guy sold it to you, they'd walk away. But I've been real impressed. Now I would not put any, you saw me get this from the back of my room, but if you noticed, I put a box in front of it. The only time I uncover this in an internal camera, because I don't want people watching me in my underwear somewhere.
Hey man, if they catch me in my underwear, that's their problem. I'll tell you that now.
But I'm just saying is, I don't. But for pointed out to the windows or out the door, or outside, then I let them run all the time. But
cool.
Some things you just can't unsee.
Yeah.
Or even unimagine.
Yeah.
Thanks, Harold.
Anytime, man. Anytime.
Yeah, there's also cell phone modules that you can get, like mine. I more or less made or used all the switches and sensors in my security system and it's tied into a cell phone module. So if somebody opens the door or window or a fire alarm or water sensors go off, I'll get a text and it'll tell me, what tripped the alarm. It's the garage door that my wife parks her car in is Ham's garage door open, or front door open or something. So
how does that cell phone tie into the cell network? Don't you have to pay for like a line for that guy to use?
Yeah, it's a you just buy a SIM card, and for text it lasts about 3 months for about $10. Pretty much anywhere in the world that you can get a text message, it'll give you a text message if there's something wrong. So
yeah, there's most of these cell phone providers have like an IoT type service. You have to ask for it. They don't really advertise it too much. It's usually a couple of dollars a month, and you get to transfer, I don't know, like $32K or something, or some low amount of money. You're not going to run your whole your phone off of the thing. You're just not going to do it. But when you got to send the doors open or not. How many bits is that? Not very many, right?
Right. Yeah, it's not much at all. Yeah, little short text messages. So, and they're, you know, the cheapest modules, the ones that don't have GPS or, you know, like the SIM 800L still works. T-Mobile was supposed to get rid of 2G, but I guess I'm not certain if that if it didn't apply to text because they were supposed to get rid of it at the beginning of 2020. And as far as I know, they're still, you can still send text with those modules. Because I've received texts and stuff. Then the other thing that you can do is you can check the status and you can set it and clear it remotely. So
yeah, one of my favorite little modules is made by Particle. If you look at particle.io, they've got Wi-Fi based and cell phone based Arduinos. I mean, it's out of the box, already connected to the cloud to do all those things that you're just saying. And they're really nice. They're nice little units. They're nice little units. For $20, I got a Wi-Fi or a little bit more. I think I got a cell phone connection. You know, I got to pay for the cell phone monthly, just what I just talked about. But I mean, it's all in one board. I plug it in a breadboard. I add some sensors to it, and I'm doing things. Right.
Yep.
Yeah. In fact, there's an Arduino. Oh, so go ahead, Ray.
Oh, the monitoring costs, you know, with the security company were getting outrageous. You know, it was like, you know, I think it crept up to like $35 a month, and you know, I didn't have any video cameras or anything. Well, I have a video camera system, but it's, you know, it's not connected to anything. So, and if both my wife and I have our cell phones, we don't have, that unit doesn't have any way of connecting to the outside because our cell phones are our hotspots. So out here in the country. So.
I was just going to mention, if you go to arduino.cc, which is the Arduino site, they sell all their boards. And I'm just looking, they've got a bunch of them now that they've just come out in the last few years that are actually labeled Internet of Things, IoT. And they generally have like IMUs on them. They've got low power Bluetooth. You know, they're really interconnected boards designed for that sort of Internet of Things world.
Wi-Fi built onto them where you don't have to add them on your
exactly.
Laying around.
Yeah, and there's I'm looking at their page, and I'd say almost maybe a third of their boards now are Wi-Fi compatible. So you know, it's a big thing for the Arduino company themselves. And I bought, the only thing was, I think I mentioned before, is I found out that the Arduino Nano doesn't support the wire slave library. So you can't use that particular one, the Arduino Nano, as an I2C slave because it's simply not in the software.
See, there you go. There you go. Being all politically incorrect again, Murray, man. Cut it out.
No. I heard about that. Yeah, I can't use the word slave, can I? Yeah. Unfortunately, that is actually the name of the wire library's methods are called slave methods.
I know.
I just made this up.
I am just poking at you, man. I'm right.
Just poking.
I'm just poking at you.
Does anybody know what a JK flip-flop is?
Yeah.
Apparently, the JKs had issues with what are called race conditions, where it's not certain, you know, when a signal is going to get there, or if it's going to get there in time, you know, for a clock hit or something. Anyway, so one of my electronics engineers explained to me that, or instructor, that to solve that problem, they created the master slave flip flop, and that's how they dealt with the conditions. So.
Now they're labeled all over.
There you just
now we have to call that primary secondary flip flop or something.
I guess.
Yeah.
So that's how it was explained. So.
Yeah. So John, what have you been up to? We haven't heard your static report. Is it scratching its bum yet?
No, unfortunately, I mowed the yard and did some other things, so didn't get to code. I did track down some of the code that I need to print out because there was some code that I had from wherever, but you know, it's one of those things, if you don't look at it, you don't remember it type thing. So need to print it out and sort of reconnect. So speaking of, let's see, you have two Daves, so we haven't heard from either. So whichever one wants to speak.
Both of them are muted.
I know. That's why I was wondering if they want to speak or not. But one will do.
Well, I'm starting to play back with some robot stuff, but not making much progress.
Yeah.
Being a semi full-time caregiver, that takes up a lot of time. So I'm trying to get back into doing some robot stuff, but very little.
I know, Dave. I've had the same issue, and I actually this week was able to spend a little time on it. It was pretty cool. Dave, you got anything to say? David Steele? Hello?
He has his speaker turned or his microphone
Oh,
turned
there
off.
you go. There you
Sorry, trying to figure out how to unmute myself. No, I don't have anything to say this time. Maybe
Okay.
this weekend I might have something to show.
Oh, sounds good. Sounds good.
Yeah.
That does bring up a question. I missed last week's. What's coming off on Saturday? Does anybody?
Well, I guess Ron Grant was supposed to do something.
Yes.
I might be able to do something if it works out.
Oh, thank you.
But I guess we can always fall back on whatever Ron's going to do. I don't know what that is, though. Does anybody else know?
I forget. He mentioned in the email Carl did what exactly it is, but yeah, he's scheduled.
I'm gonna since I have to put out some sort of web post, I'm gonna have to. I'll talk to. At least I got a target now. I'll go bug Ron.
Yeah.
So let's see what he's got. And,
Okay.
and Ray, if you're the man, I might have to hit you up. If Ron says no, it was Ray.
Oh,
I'll
No.
Okay.
no, it wasn't.
Okay. All right.
Telling me he misunderstood, or whatever.
Okay. Well, listen, guys, I'm going to have to drop off. So it's been
Okay.
cool. And somebody turn out the lights, John, because
All right, I will.
don't want. I noticed you guys went on for over 2 hours last week. Must have been a good one.
Lots of chatty Cathy.
Oh, well, it was lots of chatting last week. Well, see, we had a new Doug, and Doug had lots of questions, and we're happy to provide lots of answers. Whether Doug wanted them or not, I don't know, but we provided lots of answers.
That's right.
Yeah.
Answers you got anyway, right?
Yeah.
If you forget the password or need any help with those materials, just give me an email, and I'll try to straighten them out for you. Okay. I think you'll find that they'd be real useful for where you are right now. You're in a great place for that.
I think so.
Okay. Bye-bye, guys.
Okay, take care, Doug, until Saturday,
Yeah,
right?
till
I assume
Saturday.
it'll be on Saturday. Okay.
Yeah. Does anybody know if it's 12 or 1?
I'm thinking it was 12, but I think
Yeah.
Carl was going to post in a day or two.
Okay.
Type thing.
Gotcha. Okay.
Okay.
But
That's good. Bye-bye.
bye for now on
I'll
that.
see you.
Meantime, while I'm thinking about it, since I do have this book, this is a good book. You can see that with the lack of glare. But anyway, this one was a good book.
What's the author's name?
John Dave Warren.
Okay. Thank you.
Arduino Robots, Technology in Action. So what is that? TIA. I guess it's a publisher. A-Press.
Yeah, I'll post the link. I found it.
Good. Because I was going to say that's a pretty good book, and it gets you a couple different levels robots from a C-Wave Plus. So I would recommend that. And then they have a beginner version of it. So here's the beginner one.
Mm-hmm.
And that one, they have, use the basic motors that you have and that. So yeah, I don't know. Let's see if we can get the picture up here real better without glare. So you can see that they basically use the same motors and they just basically cut real plastic circle light, 2 circles, and sandwich it.
Mm-hmm.
So yeah, this is a pretty good book too. So I would recommend either one, depending on how big of a robot and how fancy you want to get.
I'm thinking about a Cadillac. It'll be a lot.
Start small, build up would be my answer.
Yeah.
As Dave Anderson said, get it rolling down the floor first.
Right.
Yeah.
That's why I said start small.
Good advice.
This is exploring Arduino. It kind of takes you beyond the basics and kind of gets into, parsing serial streams and that kind of stuff.
Right.
If you're sending stuff across serial or that kind of stuff. It's by Jeremy Blum. I think it's called Exploring Arduino. And he, I really liked his book. It's pretty good and covers everything from, later chapters, data logging with SD cards. So, into kind of the little bit more difficult stuff, hardware and timer interrupts, wireless
Which will be definitely good, especially if you want to incorporate different sensors all at one time. So y'all
talks about SPI, UART, and I2C, how to use those.
And it looks like Dave has another one programming something. Needs to go a little higher up. There you go.
There we go.
And then tilt down though, you get glare off of the. There you go. Now
yeah,
the guy who wrote the book on Python.
And there are a book or two of Python out there. I just don't have the offhand on me. So yeah, there's some good books out there, depending upon what chip set you're going to use and what language.
Well, I'm thinking that for the low-level stuff, I'll probably stick with the basic language for the board, which for Arduino is C. And for the Pi, I want to do my higher-level IEI type stuff in BASIC because that's what I programmed my whole life in. But I may start learning more Python because I can. I just haven't.
Mm-hmm.
I think from anyone who's done a lot of programming, at some point you get to the point where the syntax doesn't matter that much. You kind of
you got a looping construct. You got a way to assign variable. Yeah. You got an if construct.
Right.
Yeah, you just get the book out of what the syntax is.
Exactly.
Yeah. And sometimes, every now and then, like right now, I've been working with some Angular, and it's the first time I've been playing deep in or even doing anything serious with Angular. And I get the concept of observables, but how they've done it and how I expected to do it have been two different things going on there. So I get the concept, but it's just, oh, you want me to do it that way? Okay, cool. I can do it that way. Just I wish somebody would have told me that an hour and a half ago.
Well, that might bring up something for Doug in terms of what he chooses, because one of the things I've been a Java programmer for over 20 years or more. I can't remember exactly, sometime in the mid 90s. And when I started to working with robots again, I decided I wanted to do some kind of a multi-threaded application where we would have multiple processes running at the same time. And you can, of course, do that in Java, but running Java on a robot seemed like kind of a dumb idea. And even though it would be possible, what you might do is look at your basic system that you've got available on the Pi and see if it can do multi-threading, because Python certainly can. It actually has what's called multi-processing and multi-threading. If your basic language doesn't support some of the things you want to do, now it may be that you don't want to do multi-threading. But what I would suggest is looking at both the hardware and the software and say to yourself, okay, what are my requirements from my hardware and software in terms of my goals? And like I said, for me, I wanted to learn Python, and I wanted to be able to do some of the same kinds of things that I could do in Java. and also wanted to learn how to build a subsumption architecture because I'd been, like I said, reading about that. So those were my goals. And then what I did is I designed my hardware and my software so I could fulfill those goals.
Yeah.
And that's kind of where that's what the constraints were when I made the decisions on how big the robot was going to be and what programming language and all those things kind of came out of that. And like even the choice of using an Arduino or an itsy bitsy slave processor on the Pi was because I wanted to learn how to do that.
Right.
And, so if you pick this up,
I'm sorry.
So go ahead, Bill.
I didn't want to cut you off. I'm sorry.
Oh, that's all right.
I did something a little different than Murray did when I started doing this robot here in the last. I got interested because of ROS on Windows, ROS, and specifically ROS 2, and I'm like, that's what I want to do. What do I need to do to be able to do that on a robot? Because that intrigued me, how the architecture, how it was built, the fact that when I've run a bunch of samples on my Raspberry Pi 4. And I've got some stuff working on my local box, and I've got to redo my Latte Panda for the brains for my robot I'm working on now. But I've ran all the samples on those, and the very first thing they have you do, which I thought was really cool, fire up a C++ node and fire up a Python node, and they're talking to one another, and they don't care. They absolutely don't care because pick your poison, pick your weapon. As long as you're matching the interface of when you're talking to the message queues that Murray was referring to earlier, it doesn't matter what you write them in. And there's even a little bitty one, a node that will run on an Arduino, but it don't do much. Trust me on that one. But it will talk to the bus to get things and do things, right? But it won't do much. So, but it just so you get to pick your poison with a lot of these modern, more recent operating systems and control boards and all that sort of stuff. Mm-hmm. Yeah, I think that's pretty cool. That's kind of intrigues me because I grew up, we had the TRS-80 and we had the other kind of things, and this thing would never talk to this thing, and oh yeah, we'll talk to everything. Well, kind of, maybe I built an emulator that maybe runs some of these and this kind of stuff. But now we finally got to the point, 30, 40 years later that, we don't really care. Pick your weapon and make it happen. And you can make it happen. And they all talk.
And a lot of the sensors from the various vendors like Pimoroni or Adafruit, a lot of these sensors are generally either like pins that basically send either an analog or digital value, or they're often an I2C sensor. And then for me, again, it was like, well, is there a library available? I don't want to have to write. Some people might like to do this, but I don't want to have to write the library to communicate with the sensor.
This is not the problem you want to solve. You want to solve problems, not this one. Yeah.
Yeah, exactly. And so what I found was that a lot of these sensors have both Arduino and Raspberry Pi or Python or MicroPython libraries. And so when you're setting up your set of requirements for what you want to accomplish with your robot, you're looking at the sensors, you're looking at the libraries that are available, and those will often choose the language for you because if, let's say you want to have a particular sensor, it's only available in Python. Well, you're going to be programming in Python.
Yep.
Yeah. And I mean, I mentioned that there's a neighborhood girl, a 10-year-old girl that I helped her set up a little robot, and she's got the robot now, and I think I might have even reported that she's kind of lost traction. She's not using it for anything, and it's because she's got the robot, but she doesn't know what to do with it, I'm sure. And so what I'm going to have to do probably is go over to their house probably next week and sit down and make up some lessons, some actual goals. Like, can you program this robot? And she's very bright. Can you program this robot to run forward until it runs into something and then back up? Give her some actual goals that she needs to fulfill in order to get her kind of moving. And I think that's even true for myself, is that what David Anderson was banging on about with me was I had jumped into this, put like 1,000 sensors in my robot, and then I didn't know what the hell to do with it. And his advice was, well, make it move, And so I've been actually simplifying and simplifying and simplifying. And like what I can report is that this week I bought $2 worth of little tiny buttons and some stretchy thread. And that's my expenditure, $2 this week. It's one of the cheapest weeks I've had with robots, and that's to hold my polycarbonate bumper on my robot. And I've stripped back my master-slave software so that it's no longer this sort of universal I2C master-slave thing. It's actually now about a third of the amount of code, and it only does my robot. I'm not trying to support anybody else. And that took out a huge amount of the code. So that means that the Itsy Bitsy is now literally programmed for the specific pins that it's expecting my infrareds and my bumpers on. And the master software on the Pi is only going to communicate with that and only ask those specific questions. So my point is that I had gone into this giant idea of how I was going to communicate. It was going to be auto-configurable, like the Raspberry Pi would configure the Itsy Bitsy and all this stuff, and I kind of got it working, but it was so complicated. I wasn't getting anywhere. Like, the robot's not moving. It's, as David could even come in, I still can't move this robot, and that's my fault. And what I need to do is continually simplify, 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 so I can actually make the robot move.
Right.
And I think that's kind of like, okay, that's where
the key is to build blocks. So one block first, and then add to that block.
Exactly.
Speaking of sensors, speaking of another book, I had that one. So this one's from Make, and let's see, we need to go in that corner, and you'll see there that basically it says that it has Raspberry and Arduino both. So it has both code samples for the sensor. So yeah, this is another good book.
Cool. Because I've been wondering with regards to detecting distance and motion. I know that infrared's close in only. LiDAR can be further away. I'm not quite sure where sonic Polaroid sensors are.
Probably.
We talked a little bit about that last week. The infrareds, if you go digital infrared, the sharp ones have a 5 centimeter, a 10, and a 15 centimeter, and they just say yes or no. And then the analog ones run roughly from about 5 centimeters all the way till like 5 meters, for that really big one. But reliably, I'd say up to about maybe 4 or 5 feet. And in fact, I don't even know if that's reliable. I'd say a few feet. But that's for my robot, and I think a lot of people's robots, that gives you an idea. If the robot's moving at a certain speed, it gives you a notion that it may be better to either slow down or stop when you're coming up to something.
Right.
Talking LiDAR, that's a laser. It can go quite a long way. And
the the LiDAR lights are good for 40 meters outside.
Wow.
I wonder, with so much LiDAR in the world, will they get confusing to each other? Like my car uses LiDAR, but a lot of other cars are too, and it still seems to figure it out.
Yeah.
They're generally multiplexed, or they're pulsed at a certain speed. So even the little infrared ones are not just an on-off. They're actually, I think that they're pulsating at like 38 kilohertz or something like that. So they're actually sending out a pulse of light and then looking for that pulse. And so I would assume the LiDARs are doing the same thing.
Yeah.
Yeah, Intel mentioned that their technology that they used in their stereo cameras isn't affected, or they won't affect each other. But if you get two of the newer ones that looks like it's using moving mirror technology, they will. So yeah, you can't have two of them, basically shining, laser light on the same scene, because they will interfere with each other. So, but yeah, that was a countermeasure I always wanted to try with Scott, because he has one of the rotating LiDARs, and I thought if I got one of my like 35 milliwatt 850 nanometer ones, and just kept it on constant, or would it run into a wall? Yeah, the only thing that I did that tripped Scott up, the cans that we go after are fluorescent orange. They look like this, and as markers, I had probably 2 feet by 3 feet, this colored markers on either end of the goal. And he hadn't, he was just looking for it turns out the closest can gives you the biggest, blob, basically, because the optics make it larger. But with those 2 big markers in the background, he couldn't distinguish those from a can. So that was the only way I could ever trip Scott up. So
That's kind of mean, actually.
yeah, Doug quickly made a rule saying I couldn't use orange markers anymore.
So
go. I've got just got
I
a
was
notice
gonna
that
say,
getting picked up at the.
okay, so I guess I would say for you, Murray, check the calendar thing as to regard to trailfish. I don't know exactly when we're having this meeting on Saturday. I'm thinking 12, but it could be 1, but I think normally it's at 12.
Is it actually better for you, Murray, if it's 1?
I think if it's at 1, that'd be 6 in the morning.
Okay.
Oh, versus 5 in the morning at noon?
Yeah, something like that.
Something like that.
Murray, see, he's dedicated. I'm just saying.
Wow. Okay.
Sunday's my sleep in. It's kind of hard to get me out of bed on a Sunday, actually. That's the Sabbath, right? That's when I sleep.
Yeah.
I'll just drink some coffee, right? Get some strong coffee and for the hour or 2 and then go back to sleep.
Yeah.
So,
well, I've got guys. So take care.
Okay, well, take care until next time.
Okay.
I don't know if anybody else, you want to finish it up for tonight or you want to talk anymore?
No, that's good.
I'll sign out.
Okay.
Okay. Well, in that case, I guess take care until next time.
We'll see y'all.
Take care, guys. Be safe.
For now.